Hi students, this is Srinivas, mathematics lecturer. So in the previous sessions, we completed the probability concepts and miscellaneous problems also. In this session, I am going to take quick run through on probability. So taking complete summary of probability. Okay. In the probability, at first we learned about the random experiment. Random experiment is an experiment which can be performed any number of times under the essentially similar or identical conditions. And even though we know all the outcomes in advance, but in a particular case, we cannot know, we don't know what will be the actual outcome. Such experiment is said to be the random experiment. Example, tossing a coin. If we take one coin and one person and the same place, if we toss that coin, the same person by any number of times, we know what are the outcomes of that experiment, either head or tail. But in a particular case, if we toss coin, what will be the actual outcome we cannot say. Therefore, tossing a coin is a random experiment, and rolling a die, random experiment. Drawing a card from pack of cards, random experiment. Choosing a ball from containing few balls in a bag, random experiment. So these are the random experiment. Okay. Next. Now, in the random experiment, the set of all outcomes is said to be the sample space. It is going to play the major role in this particular chapter. If we are able to understand the data, then we can identify what is the random experiment. After identifying the random experiment, we'll choose the sample space. Then we'll get N of S. Number of elements in sample space is N of S. Now, the each and every subset of sample space is said to be the event, and we denoted by capital letters A, B, C, D and so on. Now, the favorable possibilities or favorable chances to the event is denoted by N of E, and we say favorable chances. Now, the probability of occurring of any event, probability to occur any event is denoted by P of E. Here we have one definition that is called classical definition on probability. What it says, P of E, probability of any event of the random experiment with sample space S, formula N of E by N of S. It means favorable chances to the event by total chances of the experiment. N of E divided by N of S. Right? This is the occurrence of the event E, and whose probability is denoted by P of E. Non-occurrence of the E is denoted by E bar, whose probability is defined as 1 minus P of E. It is known as complementary event, not happening the event E. P of E bar or E power C. Formula 1 minus P of E. Okay. Now, the probability of any event range always lies between 0 and 1. This is important because favorable chances to the event is always less than or equal to the total chances. Therefore, it is proper fraction. It should lie between 0 and 1. And favorable chances or total chances are countable numbers or natural numbers. Therefore, they are always positive. It means the probability of any event in the random experiment always lies between 0 and 1. But when it becomes 0, when it is an impossible event. What is the impossible event? Let us see. When a die is rolled, what is the probability of getting the number 7? It is not possible. Therefore, in that case, we will find favorable chances 0. 0 by total chances 6, 0. So, the probability of an impossible event is 0. So, we will get 0 also. And when we will get 1? When the event is a certain event. Certain event means it should happen. When a die is rolled, either we will get 1 or 2 or 3 or 4 or 5 or 6. Any one of them should occur there. Therefore, either getting 1 or 2 or 3 or 4 or 5 or 6 is said to be the certain event. The probability of certain event is 1. And other than impossible and certain event, whatever it may be the event whose probability always lies between 0 and 1, that is the reason the probability of an event is taken as in between 0 and 1. 0 is impossible event and 1 is probability of certain event, or we can say P of S. S means sample space. Okay. Next one. That 2 or more events are said to be mutually exclusive. If occurrence of one event prevent the occurrence of any another events, any one of the another events, such events are said to be mutually exclusive. And to prove the two events are mutually exclusive, their intersection should be pi null set, and the probability of two mutually exclusive events is 0. Okay, probability of two mutually exclusive events. If A intersection B is equal to null set, then A and B are said to be the mutually exclusive, and for such event probability becomes 0, because you cannot find the favorable chances there. Favorable chances are 0, 0 by something. So, to prove that two events are mutually exclusive, their intersection should be pi, and such event probability becomes 0. Right? Next, to prove the two or more events are exhaustive events, the union of all such events is sample space. For example, I am taking A and B. Okay. If their union is a sample space, then A comma B are said to be exhaustive events. It means if A union B is equal to S, then these two are said to be exhaustive events, and P of A union B is equal to 1. Okay, next. So mutually exclusive and exhaustive events are over. Now equally likely events. Two or more events are said to be equally likely if happening of all these events are having same possibility, equal possibility. The occurrence of the two or more events having same or equal possibility, such events are said to be equally likely. So if A and B and C and or so on equally likely, then their probabilities are same. P of A is equal to P of B is equal to P of C is equal to 1 by 3. In that sample space, we have only 3 events and all are equal. 1 by 3 plus 1 by 3, 1 by 3. So sum of these 3 is equal to again 1. Okay. In any random experiment, if only 2 events are there, then P of A union B becomes P of A plus P of B. Their sum becomes 1 because they are mutually exclusive and exhaustive. Okay. Next. This is the classical definition, this is the complementary, and this is the range of probability of any event. This is the definition of mutually exclusive. This is the exhaustive, this is equally likely. If such events are n, then you can write 1 by n. Such events are n in that random experiment, you can write 1 by n. Okay. Now, we have, after defining the classical definition of the probability, we have addition theorem. What is the addition theorem? Addition theorem is, if A comma B are the any two events of the random experiment with sample space S, then P of A union B is equal P of A plus P of B minus P of A intersection B. This is the addition theorem. Sir, when we use the addition theorem, if the data contains either A or B, at least one of them, in such case, we will take addition theorem. To take the addition theorem, we have to take the two events are A and B. For example, given that 1 to 100 numbers and we are choosing one number from 1 to 100, then what is the probability that that number is divisible by 2 or divisible by 3. Divisible by 2 or divisible by 3. Then you have to choose like this. Let A be the event that the number selected is divisible by 2. B be the event that the number divisible by 3. Then he want A union B. Then you have to write P of A plus P of B minus P of A intersection B. Here in the addition theorem, how you are defining A intersection B plays major role. Plays major role. Now in this particular problem, a number is selected from 1 to 100 is divisible by 2 or divisible by 3. Let A be the event that the number is divisible by 2. B be the event that the number is divisible by 3. Then A union B is P of A plus P of B minus P of A intersection B. Here A intersection B means the selected number is divisible by 2 and 3. Divisible by 2 and 3. Intersection means and. 2 and 3 means the number divisible by LCM of 2 and 3. LCM of 2 comma 3 is both are prime numbers 6. So P of A is divisible by 2. P of B is divisible by 3. P of A intersection B is divisible by 6. You collect such numbers, collect the favorable chances, total chances is always 100. So this is the way. When we will use addition theorem, if the data contains either A or B or both or at least one of them, in such cases we will use A union B. Addition theorem is used for the conjunction R is given. Okay. Now what is the conditional probability? Conditional probability. To define the conditional probability, we have to take conditional event. In a random experiment, assuming there are two events A and B, the occurrence of B after the occurrence of A, let A comma B are the two events of random experiment, then what is the conditional event? The occurrence of B after the occurrence of A, then B is said to be conditional event given A. B is called, second event is called conditional event. Why? It is happening after A. Let A comma B are the two events of a random experiment. The occurrence of B after the occurrence of A, then B is said to be conditional event denoted by B given A and whose probability is defined as P of B given A. Okay? And whose formula is given like this. Probability of B given A is equal to P of A intersection B divided by P of A or N of A intersection B divided by N of A. This is the way. Okay. So simple. Conditional event means occurrence of the second event after the occurrence of first. Then second event is said to be the conditional. Okay. Now after knowing the conditional event, what is the multiplication theorem? So let A comma B are the two events of the random experiment with sample space yes, then the probability of happening both A and B is denoted by P of A intersection B and it is defined as P of A into P of B given A. This is multiplication theorem. It means multiplication theorem is useful to find the probability to occur both at a time, to occur both A and B. And here, what is the word you are using? And. In the addition theorem, R. R is nothing but union. And is nothing but intersection. And means both at a time. R means either of them. Here, both of them. Okay. So, P of A intersection B is equal to P of A into P of B given A, if A is the first event. Okay. So, this is the multiplication theorem. I want both the events to occur. Then, first event A is over. Now, I am collecting the second event B after A. Right. Next, if A comma B are independent events, if A comma B are independent, then P of, what is the condition that two events are independent? P of A into P of B. It is obtained from this multiplication theorem. In what way, sir? Now listen. Excellent. Here, conditional event definition is given like this. Let A comma B are the two events of the random experiment with sample space S. The occurrence of B after the occurrence of A. Then B is said to be the conditional event given A. But if B is affected by A, or B depends on A, or B is influenced by A, then the B is denoted by B given A. B given A is nothing but the second event. But if it is depends on A or influenced by A, or after occurrence of A, B is occurred by influenced by A. It means B is depending on A, simply I can say. Then you represent B by A. Now, if B is not depending on A, then B is asking why you are representing me, B given A. I am independent of A. So, I will take my name with B only. Then in that case you will write B. That is the reason. This is the product of two dependent events. This is the product of two independent events. So this is one of the great formula in probability. One of the great formula in the probability. If A and B are two independent events, then P of A intersection B is equal to P of A into P of B. So identify the given two events are independent or dependent. Then P of A intersection B can be written as P of A into P of B. Okay. So will you give the examples, sir, how to identify the independent? Okay. Two persons are going to attend the interview for the post. The selecting the person for that post is independent. Why? According to my talent, I may get the job. Right? Getting the job by two individuals always independent, because according to their talent they may get the job. One person is doing hard work, one person is having extraordinary knowledge. His knowledge is sharing with the friend, that is the reason he got the job. We cannot say like that. Okay, so getting job by two individuals independent. Writing the examination by two individuals independent. Getting the scholarship by two persons independent. Winning the game by two persons independent. Winning the race by three horses independent. Because according to their own talent they may win the game or lose the game. So that is the reason. According to the data you identify the events, are they dependent or independent. According to that, you may use this formula or this. No need of separate notation for this formula, but independent we use this formula. So after knowing conditional event and conditional probability, whose formula, dependent, independent. Now I am moving to total probability. What is the total probability? Let us see. For example, I want probability of E. I am taking one event E. Okay. For example, yes. In a class, assuming there are 40 boys and 50 girls. 40 boys and 50 girls. In 40 boys, 50% means 20 boys know cricket and 25 girls know cricket. In such class, from such class, if we selected randomly one person, then what is the probability that selected person is cricket knowing person? So, what is the event? Knowing cricket is the event. Why it belongs to total probability? Let me explain. Total probability means what you need, what you require, you collect from all. In the class, I found 40 boys and 60 girls. Take 60 girls, okay? 60 girls. and 30 girls knows cricket. Okay. So 40 boys and 60 girls are there. In the 40 boys, 20 boys knows cricket. In 60 girls, 30 girls knows cricket. Now I selected randomly one person. Then what is the probability that the selected person knows cricket? So I am taking that event as C. Now how many possibilities are there? That selected person may be boy, P of B. Yes. I know the selected person is boy. Then what is the probability that he knows cricket? Or I selected one girl, then I know the person is girl, then what is the probability that she knows cricket? So how we are collecting the person who knows cricket? We are collecting from boys and girls. Now selecting boys means 40 by 100. In that I know he is the boy and I want cricket knowing boy, therefore 20 by 40 plus selecting girl 60 by 100 into I know the person is girl but I want the cricket knowing girl 30 by 60. Okay, 30 by 60. Here 60, 60, 40, 40 cancel. 20 plus 30, 50 by 100, it means 1 by 2. This is the way. This is called total probability, where your what is the required event and how many probabilities are there for the required. This is total probability. If we know the total probability, now what is the Bayes theorem? Right. Bayes theorem is, after giving such data, what is the data? I am reading completely the data. In a class there are 100 students in which 40 boys and 60 girls. 50% of the boys and 50% of the girls knows cricket, and randomly one person is selected. What is the probability that the selected person is knows cricket? This is the question and this is the answer. Now in what way the Bayes theorem will be asked? Let me explain. So I am reading the complete data again. In a class there are 600 students in which 40 boys and 60 girls. 50% of the boys and 50% of the girls knows cricket. Now randomly one of the person selected from class and I found the person knows cricket. Then what is the probability that the person is a boy? The person is a boy. What is the probability that the person is a boy when I know the person knows cricket? Then this is the Bayes theorem. This is the Bayes theorem. Okay. So numerator, boy 40 by 100. And how many boys knows cricket? 20 by 100, 20 by 40. When I know the person is boy, then what is the probability that the boy knows cricket? 20 boys are knows cricket out of 40. Divided by, already we found whose value it is becomes 1 by 2. So here 40, 40 cancel, 20, 5 are. So final answer we are getting 2 by 5. This is the Bayes theorem. Bayes theorem, it will ask in the reverse. Reverse means, I selected one person from the class randomly and I found the person knows cricket. Then what is the probability that the person is a boy? Direct probability means, what is the probability that the boy is knows cricket? Then we will move to the boys. How many boys are there? 40. How many of them are knows cricket? 20. 20 by 40. What is the probability that the selected boy is knows cricket? This is direct probability. Conditional probability is, if I selected a boy, then what is the probability that the person knows cricket? It means I know the selected person is boy. B. Given. Always conditional probability contains the words like this. If, given that, known that, happened that, occurred that, then we will choose what happened, what occurred, what known as A, and what we are going to find B. Then P of B given A, conditional probability. Ordinary probability means select the cricket nose boy. Then we will choose the boy from cricket nose boy from the boys, 20 by 40. Conditional probability means if the selected person knows cricket, then what is the probability of selecting boy? Bayes theorem means I selected one person and I found that the person knows cricket. Then either the person is boy or girl, he may ask like this. So ordinary, conditional and Bayes. Bayes completely reverse. Okay, he gave the event there. I selected a person at random and I found he or she knows cricket. Then what is the probability that the person come from boys? What is the probability that the person knows cricket? Then we will choose this one. The person knows cricket. What is the probability that the selected person knows cricket from boys? Then that is conditional. And select the cricket knows person, ordinary probability. We may choose from boys or girls. So like this we will find. So these are the few important points in the probability. Bayes theorem is also over. Now one infinite GP model is given. What is that infinite GP? Let us see. Two persons are playing a game by rolling a die, and who get 3 at first will win the game. They are framing one game. Rolling a die, both of them rolling a die, one after the another, and who will get 3 at first will win the game. So this is the rules and regulations of the game. And among these two persons, A and B, A starts the game. Then what is the probability of winning the game by A? Then we represent it by P of A. P of A. Since the game is started by A, he may get first chance or third chance or fifth chance or seventh chance. Sir, why? Because game started by A. In that first chance he may win the game. If he loses the game in the first chance, we will write Q. Then the second chance goes to B. He has to lose the game. Then again in the third chance, A may win the game. It means I am searching for the probability of A to win the game. Therefore, my focus should be on A only. Whenever he is getting the chance, in that particular chance he may win the game. That is the reason we are always focusing on the A chances only. First chance, third chance, fifth chance. Now, if he loses the game in the first chance, B take the second, he has to lose. And again third chance will to A. If he loses the game there only, then fourth chance to B, he has to lose. Again the third, fifth chance, like this. So here we will get some infinite GP. In that infinite GP, Q square is the common ratio and A is the P. Therefore, final answer P by 1 minus Q square. According to that random experiment, you define the success and failure. What are the P and Q? Success and failures of the game. So like this, we created the infinite GP also. Now, after completion of all the terminology and notations and definitions, we took the model wise problems. For example, coins model. For the coins model, we have only one formula, that is NCR by 2 power n. If a coin is tossed n times, then n of s is equal to 2 power n. If coin is tossed 3 times, 2q, 5 times 2 power 5, 10 times 2 power 10, n times 2 power n. Now, a coin is tossed n times, then the probability of getting smaller heads and remaining are tails. Among the n upward faces, among the n faces, among the n upward faces, he want r heads, small r heads. Therefore, for the coins model, we have one and only one formula that is taken as the shortcut, that is NCR by 2 power n. So, in what way, let us see. For the coins model, probability of the event is NCR by 2 power n. When a coin is tossed, you will get n upward faces. In these n upward faces, he wants smaller heads only. So out of n, I am choosing r places for heads, NCR. In those r places, take the heads. All are identical, you will get only one charge. That is the reason I am not writing into 1. And remaining n minus r should be tails. So n minus r, c n minus r, it is always gives 1. That is the reason I am not writing. So after simplifying entire formula, you will get NCR by 2 power n. Okay. For example, when 10 coins are tossed at a time, then what is the probability of getting 4 heads? Then 10C4 by 2 power 10. It's over. 10C4 divided by 2 power 10. Remaining 6 are for tails. 6C6 one way. All our tails can be arranged in one way. 4 our heads can be arranged in one way. So all the remaining are gives 1. So 10C4 into 1, 10C4 only. Right? Now, a coin is tossed n times. Then what is the probability of getting even number of heads? It means either 0 heads or 2 heads or 4 heads or 6 heads. It means in such case we get NC0 plus NC2 plus NC4 plus and so on plus n and so on. By total chances are 2 power n. But sum of the even binomial coefficients formula, all of you know 2 power n minus 1 by 2 power n. At last you will get 1 by 2. What is the question here? When a coin is tossed n times, what is the probability of getting even number of heads? Same for odd number of heads also. NC1 plus NC3 plus NC5 and so on. Sum of the odd binomial coefficients formula also 2 power n minus 1 by 2 power n. Final answer will get 1 by 2. Okay, this is the way. So, this is the one and only one formula for coins model. Now, for the die. If single die is thrown, then all of you know n of s is equal to 6. Now questions can be framed like this. First one, if a die is rolled, what is the probability of getting an even number? Favorable chances are 2, 4, 6, 3 by 6, 1 by 2. Getting an odd number, 3 by 6, 1, 3, 5, 3 by 6, 1 by 2. Getting a prime number, 2, 3, 5, 3 by 6. Getting a multiple of 3 comma 6, 2 by 6. Like that, we can create so many problems when single die is rolled. Now, if 2 dice are rolled, then the sample space contains ordered pairs. Why? When 2 dice are rolled, the upward faces are 2. In those 2 upward faces, what are the numbers? We cannot say. How many possibilities you will get when 2 dice are rolled? If 2 dice are rolled. Okay. 2 dice are rolled. N of s is equal. Upward faces are 2. Each face will have 6 chances. 6 square, 36. N of s is equal to 36. Sir, in what way you will get 36? They are like this: 1 comma 1, 1 comma 2 and so on. 1 comma 6. 2 comma 1, 2 comma 2 and so on. 2 comma 6. and so on. 6 comma 1, 6 comma 2 and so on. 6 comma 6. So this is the sample space in which 36 sample points are there. Therefore, n of s is equal to 6 square 36. Is it clear? Now, for this random experiment of rolling 2 dice, I gave one shortcut to collect the favorable chances for the event. Okay? So, favorable chances and sum of the points. Sorry. On the 2 dice, we will get 2 numbers. Now I am taking one random experiment of sum of the numbers on 2 dice. Sum of the numbers. Sum of the numbers and favorable chances. Okay? Now, when 2 dice are rolled, what is the minimum sum? 1 comma 1 will be the minimum. 1 comma 1 means minimum sum is 2. And what will be the maximum sum? 6 comma 6, 12. So, you write 2 to 12 numbers. 2 to 12 numbers in the first horizontal line. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, for the sum on the 2 dice is 2, you have only one favorable chance. Therefore, favorable chances 1. Whatever it may be, the last also you will get 1. What is the last sum? 12. Now I am framing one shortcut. Then here you will get 2. Here also 2. Here you will get 3. Here also 3. 4, 4, 5, 5 and it is 6. Now I am framing so many questions on this table. Better to remember this table. No need of searching for the favorable chances. Minimum sum is 2 and maximum sum is 12. 2 to 12 you write the numbers and whatever the answer here in the first blank you will get the same as in the last. Okay. After constructing this table, now I am reading few questions. When 2 dice are rolled, what is the probability of getting their sum? Sum on the 2 faces is, for example, I want 10. Then 3 favorable chances are there. 3 by 36 is the answer. When 2 dice are rolled, what is the sum on the 2 faces of the dice? The sum is prime number. Then the sum is prime 2, 3, 5, 7, 11. So 1 plus 2, 3. Plus 4, 7, plus 6, 13, plus 2, 15 by 36. Like that, whatever the question he is asking, sum on the 2 dice, sum of the numbers on the 2 dice, then you may use this table. Similarly, I gave one more table when 3 dice are rolled. First of all, 3 dice are rolled, what is the n of s? 6 cube. In that sample space, you will find ordered triads. Ordered triads. Ordered triads. Sample space should contain like this: 1 comma 1 comma 1, 1 comma 1 comma 2, and so on. At last, you will get 6 comma 6 comma 6. It means n of s is equal to 6 cube 216. 216. Now, the question may be like this: what is the probability when 3 dice are rolled? Sum on the numbers, sum of the numbers on the dice. It may be 12 or 13 or 18, whatever it may be. So for that I am giving one more table: sum of the numbers and favorable chances. Sum of the minimum sum is 1 plus 1 plus 1, 3. and maximum sum is 18. So better to write 3 to 18. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, yes, sum of the 3 dice is 3, then you will find only one favorable chances. Therefore, here 1, at last to get 18 also 1. Now I am giving you one shortcut to fill these blanks. 1 plus 2, 3. Here also 3. You know how you are getting these numbers. You observe that logic. 1 here 1 plus 1, 2 plus 1, 3 plus 1, 4. Just you are adding plus 1. Here 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15, 15 plus 6, 21. Here also 3, 6, 10, 15 and 21. But these 4 blanks will have different numbers. They are 25, 25, 27, 27. These 4 not follows that logic. What the logic here? 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. Same as this from the end also. But the middle 4 are following different. 25, 27, 27, 25. It means 2 different numbers, 25, 27. You remember remaining 2 also same. So after knowing this table, how the questions will be asked? How the questions will be asked? If 3 dice are rolled, what is the probability? What is the probability that the sum on the 3 dice is 15? Then directly 10 by 2, 16. Sum on the 3 dice is a prime number. Sum on the 3 dice is a composite number. Sum of the 3 dice is multiples of 3. Sum of the 3 dice is multiples of 4, whatever it may be. So we can solve all the questions by using this table when 3 dice are rolled. Okay. Now after completion of dice model, we entered into the pack of cards. To solve the question on pack of cards, we must and should know the classification of pack of cards. Most of the students are making mistakes at the classification only. The classification of pack of cards is given like this. All of you know pack of cards contains 52, in which we'll find 2 colors, black and red. Black are 26, red also 26. And black are again of 2 types. What are they? Clubs and spades. And red are again 2 types. What are they? Diamonds and hearts. So each contains 13 cards. Okay? Once again here. Pack of cards contains 52, in which black 26 and red also 26. Black again divided into 2. The first one is clubs, second one is spades. And red are again 2 types, diamonds and hearts. These 4 are said to be suits, S-U-I-T-S. So in a pack of cards, how many suits are there? 4 suits. Each suit contains 13 cards. Now what are they? Each suit contains 13 cards. What are they? Let us see. 2, 3, 4, 5, 6, 7, 8, 9, 10. These are called number. number cards. Number cards. How many are there? 9. So in the pack of cards, each suit contains 13 cards. In 13, 9 are numbered cards. And Jack, it is also known as Knave, K-N-A-V-E, Knave, Queen, King. These 3 are called picture cards, face cards, court cards. All are same. Picture cards, face cards, court cards. And the last but not least, it is called ace. Ace card. So total 9 plus 3, 12 plus 1, 4, 13 cards are there in a pack of cards. These 9 cards are called number cards because on those cards we will find numbers only. Jack, Queen, King, we will find the pictures or faces. Therefore they are called picture cards. And last one is ace. On that card we will find A, the letter A. But if we include these 3 and A, these 4 are called honor cards. Okay, this is the classification of the pack of cards. So how many number cards are there in pack of cards? In each suit we are having 9. Such suits are 4. Total 4 9s are 36 number cards are there. And how many face cards are there? In each suit we are getting 3. 3 4 are 12 face cards are there. So by this the classification of pack of cards also over. In what way we are finding the questions on pack of cards? Let me explain. 2 cards are drawn from pack of cards, then what is the probability that they are of same color? Then N of S is 52C2. We have 2 colors, therefore take any one of them in 2C1 ways. Each color is having 26 cards, so take any 2 26C2. So 2C1 into 26C2. Now I am asking one more question on pack of cards. 2 cards are drawn from pack of cards. What is the probability that they are of different colors? Then 52C2 is N of S and we need they are of different colors. Therefore, I am taking one card from black cards, another card from red cards. How many black cards are there? 26. 26C1 into 26C1. Now, 2 cards are drawn from pack of cards. What is the probability that they are kings? How many kings are there in the pack of cards? 4. We need 2. 4C2 by 52C. What is the probability that the drawn 2 cards are numbered cards? How many numbered cards are there? 36. 36C2 divided by 52C2. This is the way to solve the questions on pack of cards. According to the data, you classify the pack of cards. In general, this is the classification. This is the skeleton. But according to the data, we may change. Okay? So, this is the pack of cards model. By this, we discussed, again we revised all the concepts in the probability. Okay? So, in the next session, I am going to take objective questions or previous objective questions, IIT models on probability. Okay? Until all of you, bye and have a nice day. Thank you.